Hello guys, welcome to my channel. So today we are going to talk about JUnit 5. So JUnit 5 is the latest version that we have with JUnit, and if you are not aware about JUnit, then JUnit is one of the most popular unit testing framework which we use whenever we are working with Java applications. So this video is going to be not for absolute beginners but for those who have some exposure towards Java as well as JUnit 4. So if you are aware about these two, then this video is for you. So before we move on to the coding part, if you are new to my channel, if you haven't subscribed to my channel yet, please do. Now let's talk about JUnit 5. Alright, so now that we are here, first step is going to be to open up your IDE and create a new project. So here I'm using IntelliJ, and here we don't have to do anything. My default build system is Maven, language is Java, and everything is all set. So here I'll just do JUnit 5 sample project. That's it. So one thing to note here is that if you are going to use JUnit 5, then you must have at least Java 8 version installed. So that is a must here. So I'm currently using Java 17 here, so I don't have that issue. But if you are going to work with Java 6, then JUnit 5 is not going to work with it. So do remember that. Now to set up your JUnit 5, you only need one dependency. So let's first create dependencies tag and then insert the dependency. So this dependency I have copied from the Maven repository. Whatever newer version you have, you should always work with it, right? So for me it is 5.9, but maybe for you in near future it is going to be something else. So don't copy or use the exact version in whichever video you are watching. Always refer to the newer version. Right, now let's download these dependencies. Alright, so it's done, and I do see that I have JUnit Jupyter API, and then I have platform as well as some other dependencies, right? So we will talk about these Jupyter platform later on, but right now one thing and the last thing to notice here is that we only need this dependencies as of now. There are other dependencies also, but we are not going to cover that in this video because here we are just going to keep it simple. So this is the only dependency which we are going to need in this video. Now let's move on. Again, one more pointer is if you have an IDE which lacks support for JUnit 5, then what you can do is you can use Maven Sunfire Provider, and to do that you just have to use this plugin, right? So right now we are using IntelliJ, or let's say your Eclipse, which do have the support for JUnit 5, so there you won't see any kind of issue. But in case you have that, then yeah, you need to have that plugin, right? Now let's talk about Jupyter and platform, which you can see here. Now what are these? So in JUnit 5 architecture, we have three most important components which you can see on my screen here. So these three are your Jupyter, Vintage and platform. So here you see the dependency Jupyter and platform, but you don't see Vintage here, right? So let me elaborate or give you a brief about these three components. So talking about JUnit platform, so testing frameworks are launched on the JVM by the platform. It specifies a reliable and potent interface for JUnit users such as build tools. So to find and run tests, the platform easily connects client with JUnit. Additionally, it specifies the test engine API for creating testing frameworks that utilize the JUnit software. So we can easily integrate third-party testing libraries into JUnit by developing a new test engine. Now talking about JUnit Jupyter, so JUnit Jupyter is going to be our most important component here, because JUnit Jupyter provides a blend of new programming models for writing JUnit test and models for extension as well. So it also introduced a lot of additional new annotations like before each, after all, before all. Then we have a lot more like display name and your nested test. Then we have a lot more which we are going to cover in this video. Now the last component is JUnit vintage. So with JUnit vintage, what do we get is we get something like what we have with Xbox Series X. So if you are familiar with it, then that's good, but if you don't, then let me tell you, like, Xbox is a console where you can play games. So with Xbox Series X, which is the latest console by Microsoft, so here what you do get is, like, you can play the new games as well as you can play the old games which were supported by the previous version of Xbox, right? So here what you can do with vintage is, like, if you have JUnit 5, then you can run those tests of JUnit 5, but you can run JUnit test cases of JUnit 3 and JUnit 4 as well. So that is what you get, like the backward compatibility is what we are getting here. Now this was all about the architecture. Now let's do the actual stuff, which is what did we get with annotations and how can we use it. Now let's talk about that. So what I will do is I will create a separate class for putting out a demo for each type of annotation, right? So first we are going to talk about before all and after all, right? So before and after annotation. So when we say before all, so this annotation is going to execute a logic once before all the test cases gets executed within the same class, which means that if you have, let's say, 10 test cases, then it is going to execute a logic once before all the test cases, those 10 test cases, right? So one important thing to note here is that the method on which you are going to use the before all annotation needs to be static. So let me give you the example here. So if I do void and let's say my test, let's say test before all, and let's annotate this with before all. Now I'll just simply do I'm going to run before all test, right? Now let's have a test. So here I'm not going to add a lot of test cases, just a single one, because that is going to take some time. So let's do here test 1, and here let's annotate this with test. So what will happen if I run this test? As I said before all annotation needs to be used with a static method, right? So let's run this and see what it is saying. So here if you see, the test was ignored, it didn't run because before all is going to execute before your actual test, and that is what happened. And then we got a runtime exception saying before all method must be static unless the test class is unannotated with test instance, right? So this is what we have to do here. So if I just do static and if I run it now, then it should be fine. So it's all green and it is also printing me what I have said in my before all method, right? So this is that. Now similarly, the same case is also for your after all annotation. So if I copy this, modify this a bit, now this is going to get run after each test case, but this method has to be static again, right? So that is that. Now if I add another test case here to provide more information, let's run this. So here you see that I'm going to run before all test and I'm going to run after all test, and in between we got the test 1 and test 2. So this is what you get with before all and after all. Now if I do before each and after each, these two methods or these two annotation doesn't need a static method. So one thing to notice is this one, that they don't need a static method. Another thing to note is that if I run in this scenario along with our before each and after each, then it is going to run with each test case. So here they are going to get called before each test case, right? So now let's change this and see what happens? So here let's do each instead of all. Again each. Alright, now let's run this. So here first thing to notice is before each method must not be static, right? So let's remove these, we don't need them anymore. Now let's run them again. Now here I'm going to run before each test, and then I got test 1. I'm going to run after each test, and then before, and then test 2, and then. So I think this part is very much easy and it should be clear and crisp right now. So let's move on to another annotation, which is going to be display name. So let's create another class. So let's first talk about why should we use display name. So display name, as the name stands for, it is a display name. So if I have a test, in this example I can see that this is test 1 and this is test 2. So in real world scenario or in your real project, this name is not going to cut off, right? No one is going to understand in this output what this test 1 is doing, what this test 2 is doing, right? We cannot see the logic, we are actually just seeing the names here, right? So what happens is we want to provide a name which can be an alternate of this name, right? And that is what we can do with display name. So display name is an annotation which is used to define the name of the test which is displayed to the user. Alright, now let's use them. So here I'm going to create a test. I'm going to use my display name annotation, and then I'm going to create my test, and here I'm again going to use test 1. And then let's do system.out.println, and here let's do executing test 1. In my display name I'll just say this is test 1. So this is not something which is different from this one, but this is just an example that whatever you provide here is going to get displayed to the user. So this is my output window here. Here I see the name which is in my method definition, but now I won't be able to see it. So let's run this. So here what do you see? Here you are seeing what we provided in my display name annotation and not what I provided in my method definition, right? So this is your display name annotation. Now let's talk about disabled annotation. So again, as the name stands for, disabled is an annotation which is used to disable a particular test case or a test class entirely, right? So let's say if you have a test class as this one disabled annotation, you can disable this class entirely, which means that whatever test cases you have inside this test class are going to get disabled. Also, you can use this annotation only on a specific test case, right? So let's talk about again our real world scenarios when I'm going to use it. Let's say if I have 100 of my test cases and my one test case is not related to my logic which I have just created, but it is affecting, or let's say it is affecting your performance, right? So just to check and not wait for it entirely, you are sure that you can, if you can just skip the test case, then you can see the desired result, then you can disable a test case. Or let's say if you are waiting for some other module to get developed, right? And that module is what or why you have created this test case. Then if that module is in development phase, then you can disable this test case for now, and later on in future you can enable it by just removing this annotation, right? So this is how you can use it, or where you can use it. Now let's see an example here. So again, I'll just do test 1 and let's say this is test 1. Alright, so now let's run this. Okay, I see my problem here. So here previously I used to get the option like run disabled annotation dot test1, right? So specifically IntelliJ was asking me to run that test method itself, but because I have used disabled, I should not be getting that option, which I'm not getting right now. What I did is I restarted my system and somehow it is working fine, right? So this is weird, I know, but now if I run this, so as you can see, I got it and it's not working, right? So this is disabled and you can see the icon specifying that this is disabled. So this is an example of disabled, and same which we can do also. So did you see one thing here, that what I'm writing here is also getting displayed here? So I can say that the feature is still not up, so disabling, right? So this you can do. Also you can do it, like I said before, on the class level as well, so it will disable the entire class. Now let's move on with assertions, because there were a lot of new things with assertions. So with assertions, like we already had them before JUnit 5, these are not new, and assertion methods are all static, right? And each method is used to see if the condition or the result is true or not. So with JUnit 5, what we can do is we can also use lambda expressions with assertions, and now assertions have been moved to package, which is your org.junit.jupyter.api. Now let's take an example here. So let me first create a new class. So let's annotate this with test. Let's name it test assertion. I'll have a list of integer. Let's import this. So here let's do 1, 2, and 4. Now what I will do is I'll use assertions with Java 8 features. So I'll just do assert equals, and here my expected result, then what is my actual result. So here the name is integer list, so I'll stream over it, then I'll just map it to int, and then integer int value, and then I'll just do sum. So what is happening is the sum of these three numbers is going to be 7, which is my expected, and if in case it is not equal, then I'll just do sum is not equal to 7. Let's refactor this a bit. So now if I run this, so it should work fine, because here whatever I'm expecting is matching with my actual result, so it should be green. But if I change this to 8, so here you see that it failed, and I'm also getting the message which I have here, that sum is not equal to 7, expected is 8, but actual is 7, right? So this is what we get with assertions. We can have lambda expressions with our assertions now. That is why it is a must to have at least Java 8 version with your JUnit 5, right? Now let's move to assumptions. In the class assumptions, all the methods are static again, and they will only run a test if the required condition is satisfied. So it's like I'm assuming that if this condition is true, then do something, right? So it's like that. So they are if I'm using assumptions, then they will only run a test if a required condition is satisfied, else the method or the test will be aborted. So the failed test won't result in a build failing, but test aborted exception is going to get thrown and the test is going to get skipped when an assumption is incorrect. Now let's take an example again. So let me create a class. Alright, so let's add a test. Let's say test1. Alright, so here let's do assume true. We will talk about assuming that also. So here what I'm going to do is I'm going to have my setup method or init method in my before all annotation. So it is going to be static. So let's say init. So here what I'm going to do is I'm going to set a property which I'm going to use later on. So set property and let's say app mode, and this is going to be dev by default, right? So in my assumption what I'm going to do is if dev dot equals system dot get property, here I'll do app mode which I have created above. Now if that is true, so if it is equal, then that is good, right? But if it is not equal, then I'll just print a message that okay, caps is on, aborting as the mode is not dev. Alright, so if this assumption is true, as in if my app mode is equal to dev, then it is going to go to the next line, which is going to be my assertions dot assert equals. So here I'll just do a simple calculation which is going to be this, right? Now if this dev is not, like if the app mode is not dev, then it is going to print this message and it is not going to come down to this. So now let's first run a simple successful run and then we will talk about the unsuccessful one. So here you see that it is green, working fine as expected. Now let's change this to dev1. Now let's run this. So here you can see that there is an exception which is test aborted exception, and it is also saying the message which we did as aborting instead of aborting as the mode is not dev. But yeah, we got the message, right? So this is what we get with assumptions, right? Now let's move to another annotation which is going to be nested test annotation. So with nested test, what we get, like the name is pretty much clear, right? So with nested test we can build nested classes and then we can run each of their test methods in a bundle, right? So in let's say if I have an inner class, so that doesn't need to be static here, and to run all the test methods inside the inner class, then I can just annotate that inner class with nested annotation. So let's take an example here. Alright, so here I have tried to use a lot of things so that I can explain in a bundle again, right? So what I have done is taking the example again from the previous one. So I have used a setup method. So here I have just a simple property which is app mode, similar to the last example. So here if you see, I have also used display name annotation. So this is my inner class and it is not static, as you can see, and it doesn't need to be, and this class is annotated with my nested annotation, and this entire class is going to get displayed to the user as all dev environment test. So it is just a categorization, so I can have multiple nested class and they could be of different environment. So it is just like beautifying your code into bundles so that you can see, okay, these all are dev test, these all are production test, right? So that you can do with your nested, and you can then run them singularly or in a bundle. Now you can see another annotation which is tag annotation. So it is nothing but a tag. So I'm using dev here as a tag, also I can run my test cases based on a tag. So let's say if in future I want to run only dev test cases, then I can use a tag, and then I'll make it that okay, run only tag with dev value, right? So then it will only run dev test cases. And similarly I have here also display name. So I haven't done anything here, I have taken example of assuming that here. So it is similar to what I have before, but here I have also used disabled annotation. So I'm just bundling each and every annotation what we have learned so far. So this is not going to get run, but you can see that assuming that and assume true, these two are similar, but what happens is here inside we can use assert equals. So this is also kind of a bundle. Here we have two different statements, here we have only one statement. So like a statement within a statement, right? So they both are doing the same thing, not different, but the way of writing it is different. So if I run this now, so here you can see that with IntelliJ I'm not even getting the option of running test2, I'm getting this option test1, and this is what I got previously also when I was having problem with disabled annotation, and right now I'm also having that issue, right? So let's run this, let's see what we get. So here you see nested annotation, right? This is what get displayed as your class name, and then I got my display name, which is your all dev environment test, which is this one. And then I got my first display name of my first test case, and because it was green, so it didn't had to display anything, so that is why it just ran successfully. So this is your nested annotation example. Now let's move on to the last topic, which is going to be the exception testing, right? So exception testing, so let's say there could be instances where procedures must throw an exception. Procedures could be your test cases, or if you have database connections, then let's say those test cases, right? So let's say during a circumstance or during a particular situation you expect an exception, right? You want to see if it is throwing an exception or not, right? Because we also do fail safe and fail fast scenarios. Let's say if I know that this is going to get failed, then let's test it, because that is my expected scenario, right? So in that case, if I do know that my scenario is going to throw an exception, then I can test it out using my exception testing. So this is all gibberish in theoretical, but let's create a class and see the example. Alright, so here I'll just have my test, let's name it test exception. Okay, so I have assertions, and then I have my all static methods, right? So then if you notice, there is one method assert throws, which we are going to use here. So my expectation is that I'm going to get a runtime exception, right? It could be your custom exception also, but in my scenario I'm just going to use this. Now I'm going to generate an exception by using my lambda expression, because I can use them. Right, now let's just do throw new runtime exception, and let's say an exception. Right, let's close this. Now later on, if it comes down to this, then assert equals, I'll just say an exception. So this is what I'm expecting from my exception message. So I'll just do, okay, I didn't store this in a variable, so let's do throwable ex. Can get the message. Here I'm also matching the message as well. So now first, if I run this, it is going to be successful, right? Because everything is proper. So it is proper, right? What if I don't display any exception? So let's do here int a equals to 1 plus 2, right? So right now it is not throwing any exception. If I run this now, so it fails. So it says expected a runtime exception to be thrown, but nothing was thrown, right? Now let's say if the exception was thrown but the message is this. Now what will happen? So here if you see, this got passed, this assert throws got passed, but this assert equal got failed, because whatever I'm expecting here is not matching with my message, and that is here, right? So this was all about JUnit 5 in my simpler terms. So if you have any questions, do point them out in the comments of this video, and if you have any kind of suggestion to what I can make a video on, then please also let that known on the comment section. So this is it for this video. I really hope that you have a wonderful day, and I really hope that you are staying safe and healthy. So this is it for now. I hope we will meet in near future. Till then, have a good day, stay safe, and bye bye.